Chemistry 2021.
Hey everybody, welcome back to chemistry. We're continuing our unit on chemistry math. But before we get started, we're going to first do a quick recap. Last time we left off, we talked about significant figures. We said that if you're multiplying and dividing, you use significant figures. If you're adding and subtracting, you're going to look at decimal place, okay? Now, to count the number of significant figures, you follow these 4 simple steps and you can do it. First one is all real numbers are significant. That's 1 through 9. Front zeros never count. It's a front zero till you hit your first real number. Sandwich zeros always count. So that's zeros between 2 real numbers. Remember, it doesn't matter how many zeros there are. As long as there's a front number and a back real number, then they count. Number 4, there's a criteria here. Back zeros count only if there's a decimal. I don't care where the decimal is, just as long as there's a decimal somewhere. Okay? Then I gave you this number right here that had 6 significant figures. The front zeros don't count. Here's the first real number. Here's the last real number. These 2 sandwiched zeros count, and these 2 back zeros count because there's a decimal. So there's 1, 2, 3, 4, 5, 6 sig figs here. And then we talked about scientific notation, okay? Now, to do scientific notation, I said first you have to find the first real number. Once you found the first real number, you're going to move the decimal behind the first real number, like this. This example, if x was a number, okay? Then you got to count how many times you move the decimal. Remember, you go times 10, and n represents the amount of times you move the decimal, okay? So then I gave you this breakdown right here. Let's do big first. If you put a big number into scientific notation, you got to move the decimal to the left, right? And then your n will always be positive. If you take it out of scientific notation, you're going to move the decimal to the right. And then, how do you tell it's a big number? If it's in scientific notation already, your n will be positive, okay? Now, let's look at small numbers. If you want to put a small number into scientific notation, you got to move the decimal to the right. And when you do times 10, remember that exponent has to be a negative number. Negative however many times you moved it to get it to the right place. If you want to take a small number out of scientific notation, you're going to move the decimal to the left, okay? How do you know it's a small number? Because your exponent's going to be negative. So that's where we left off last time. Today, we are going to talk about dimensional analysis. So what is dimensional analysis? It's just a fancy word for conversion. What is a conversion? Well, it's this. If I say I have 4 quarters, right? If I say I have 4 quarters, what does that equal? Well, I know that 4 quarters is equal to $1, okay? That's a conversion. I just did a conversion. 4 quarters equals $1. I just did it in my head. Really nice and simple, okay? Now, because we know that 4 quarters is equal to $1, we can use this to do other conversions. We call these equal quantities conversion factors. Now, in my class, and pretty much in life, you will always have the conversion factors, whether it's a chart, a list, or whatever. You will always be given the conversion factors. What I'm going to do today with dimensional analysis is teach you how to do these conversions so you can keep track of all your units and just make it way easier. It's a format that you're going to use. So let's get started. The easiest way to do this is to give you examples. So let me give you an example. We'll use time. We're going to do a time example. Let's say I work 25 days this month. If I work 25 days this month, how many seconds did I work? 25 days, how many seconds did I work? Well, to do this conversion, I'm going to need some conversion factors before I get started, okay? So let's break down conversion factors. Well, I know that 1 day is equal to 24 hours. What are the conversion factors I know? I know that 1 hour is equal to 60 minutes, okay? And I know that 1 minute is equal to 60 seconds. So I have all my conversion factors that I need. So now I got to actually do the math problem. If you follow my steps, you should be able to do any conversion you're ever given. All you care about is your starting point, which is 25 days, and your ending point, which is seconds. I got to go from days to seconds. All I care about is my starting point and ending point. So here's how we're going to do it. We're going to use the railroad track system or the dimensional analysis system. You're going to start off with what they gave you. Start off with 25 days. Now, the next part is you got to figure out how many steps it's going to take you to get to seconds. Well, look, we have our conversion factor. We got to convert days to hours, that's step 1. Hours to minutes, that's step 2. And minutes to seconds, that's step 3. Right? This is a 3-step problem. Because it's a 3-step problem, I'm going to write out 3 sets of these boxes, just like this. Okay? That's all you got to do. However many steps you got, that's how many box sets you put. However many steps you have, that's how many box sets. Now, it's really simple setting up this box. Now, at this point, we don't care about numbers. All we're going to put out is units. You always put out your units first. Once all your units are put out, then you can put out numbers. Units first. I got to fill this up all the way to seconds. And it's not hard. This is what you started off with, was in days. Now, here's the trick. Whatever's up here goes down there. So if you have days up here, you're going to put days down here. And where you want to go goes up top. So let's restate this. Whatever units you have here, you always put down there. And where you want to go goes up top. So where do we want to go in step 1? We're going from days to hours. So I'm going to put hours right here. Okay? Really simple. Now let's do step 2. The rules don't change. Whatever's up here goes down there. And where do I want to go goes up top. Whatever's up here goes down there. So hours go right here. And then now that we're in hours, where can we go to? We can go to minutes. Okay? Now we got one last step to do. Let's do it. Whatever's up here goes down there, right? Whatever's up here goes down there. So I know minutes is going to go down here, and where I want to go goes up top. From minutes, where I want to go? To seconds. Okay, so now we filled out with the units. This wasn't hard. Whatever they give me, start me off with, whatever's up here goes down there. This is what they started me off with. Okay, am I ending up in seconds like they wanted me to? Yes. Okay, so now it's time to plug in numbers. The numbers all come from your conversion factors. We don't have to figure nothing out. Okay, the hardest part is filling out this chart, but that's not hard because whatever's up here goes down there. Where you want to go goes up top, and it keeps the process going. So days, when we're right here, there's 1 day to every 24 hours. Let's do step 2 now. There's 1 hour to every 60 minutes. Easy. Now, the final step, there's 1 minute to every 60 seconds. We're done. That's really that easy. And your last step, you're just going to multiply and divide. You're going to multiply the top together. You're going to multiply the bottom together. And you're going to get 2 separate numbers. So I'm going to pull out my calculator real quick, and we're going to do the top part first. Now, don't forget to enter your 25 days. We've got to multiply the entire top, okay? So we're going to go 25 times 24 times 60 times 60 equals 216,000. Okay, good. Now let's do the bottom. 1 times 1 times 1 equals 1. And your last step is to divide, right? Top and bottom. Your last step is to divide. So that divided by 1. So your final answer is 216,000. Oh, there's actually a 4th 0 here. So I'm going to put my commas in there. So I can tell you that 25 days is 2,160,000 seconds. Okay? That's dimensional analysis. Really, really, really simple, guys. All you got to do is follow these rules. Sometimes there's one-step problems. Sometimes there's two-step problems, right? Let me do one more example with you just to make sure you got this. So I'm going to give you some conversion factors. I know that 1,000 milliliters is equal to 1 liter. And milliliters is actually equal to cubic centimeters. Just so you know in future text that milliliters and cubic centimeters is the same, okay? So let's do this problem right here. Let's say I have 50,246 milliliters of water. And I want to know how many liters of water that is, right? I'm going to look up my given chart. This would be like a chart that somebody would give you, your conversion factors, right? So I'm going to look. Oh, look, I'm in milliliters, and I want to go to liters. Milliliters to liters. That's just a one-step problem. It's not like here where I started off with days, but all I could get to was hours, and once I'm in hours, all I could get to was minutes, and so it had to be 3 steps. This one is just a one-step problem, okay? So I'm going to start off with what they gave me, 50,246 milliliters, right? It's a one-step problem because I have to go from milliliters straight to liters, so I'm going to draw one set of boxes here, okay? So now, who remembers what we have to do? I said whatever's up here goes down there every time. Whatever units is up here goes down there. Not the number, just the unit. Whatever's up here goes down there. So I'm going to put milliliters. Okay? Now, once I'm in milliliters, where do I want to go to? I want to go to liters, right? Now it's time to plug in the numbers. Where did the numbers come from? The conversion factor right here. What number does milliliters get? Well, here's milliliters. He gets 1,000. What number does liters get? He has a 1, so liters get 1. So nothing changes. We're going to multiply the top together. So 50,000, that equals 50,246 times 1, so it's the same. There's nothing to multiply at the bottom, so we're going to carry that 1,000. So we end up with that number divided by 1,000. Okay? So if I punch that into my calculator, I end up with 50.246 liters of water. And that would be your answer. So 50,246 milliliters is equal to 50.246 liters of water. Okay? This was a one-step problem. But guys, you do dimensional analysis the same way. You look at your chart, you figure out how many steps it's going to take, and that determines how many sets of these boxes you're going to use. Okay? Whatever unit they start, first write what they started you with, and then whatever's up here goes down there, and where you want to go goes up top. That is dimensional analysis, guys. And if you can learn dimensional analysis, not just in chemistry, but everyday life will get a lot easier. Hope this helps you, and have a great afternoon.